This is 12-5 angle relationships in circles. Try the 3 warm-up problems and hit play when you're ready to see the answers. Here are the answers to the warm-up. So to identify each line or segment, my options are chords, tangents, secants, radii, and diameter. So I listed those all out, but I only had chords, tangents, and secants in this case. And for number 2, it was a central angle, so it's equal to its arc measure. And for number 3, it was an inscribed angle, so it's equal to 1/2 of its arc measure. This theorem actually just reminds me of an inscribed angle still, so to me it kind of follows the same thing. Since it's hitting the edge of the circle, it's just not made up of 2 chords. In this case, it's made up of a tangent and a secant. And so it's still equal to 1/2 of its arc measure. So its arc measure would be like arc AB, what's inside of it. So let's read it. If a tangent and a secant or a chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. Okay, measure of angle EFH, so I'm just highlighting that, and I can see based off of this chord and tangent that my intercepted arc is right here, 130, and so this is going to be equal to 1/2 of arc FH. So the measure of angle EFH is equal to 1/2 of 130, which is 65 degrees. Okay, and then I'm looking at this next one. They want measure of arc GF. Well, arc GF is right here. GF. And I had a linear pair in here. So if I do 180 minus 122, I get 58 degrees. And so this is 58 degrees. And so if I'm looking for arc GF, the angle 58 is equal to 1/2 of the arc, 1/2 of the measure of GF. And so I divide both by 1/2, which is really like multiplying by 2. And so I get 116 degrees is equal to the measure of arc GF. Okay, notice we don't know the center of this circle. So we don't have information there, but what we have, it says if 2 secants or chords intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. It's almost like an average. So if they're meeting in the middle, then the measure of the angle formed, like the measure of angle 1, for instance, is equal to half of AB plus CD. So it's like adding them and dividing by 2. It's taking the average, basically. If they're meeting in the interior, that's the key word there, interior. So here I have my lines meeting in the inside of the circle. So I know when I'm looking for the measure of angle AEB, since it's in the interior, it's going to be measure of angle AEB is going to be equal to 1/2 of 139 plus 113, or you can just average them, add them, and divide by 2. This comes out to be measure of angle AEB is equal to 126 degrees. Now, if the angle is in the exterior of the circle, then it's going to be half of the 2 arcs subtracted from each other. And there's a few scenarios that could happen. So look at what it says here. If a tangent and a secant, so that's stated here, a tangent and a secant, or if 2 tangents, like in this example here, 2 tangents, or 2 secants, as shown here, any of those scenarios, intersect in the exterior, that's the key word, the exterior of the circle, then the measure of the angle formed is half the difference of the measures of the intercepted arc. So instead of adding them, we're going to subtract them and then divide by 2 or take half. So to find the value of x is going to be equal to 1/2 of the arc measures subtracted from each other. So the measure of angle x is equal to 40 degrees. Okay, here we have lines that are meeting on the outside, forming an angle outside of the circle in the exterior. So I know it's going to be subtraction. So the measure of angle x is equal to 1/2 of 200 minus 74. So the measure of angle x is equal to 63 degrees. So I've marked up my circle with what was listed here. So measure of arc FH was 108 degrees. Measure of arc LJ is 12 degrees. And I'm looking for the measure of angle FKH. So those are the two arcs coming off of this secant and another secant. And so that's going to be equal to 1/2 of the two arcs subtracted from each other. So 108 minus 12 degrees. And if you calculate that, you get measure of angle FKH is equal to 48 degrees. Take a second, try the now you try, and hit play when you're ready to see the answer. So this is really the same idea. The measure of angle PRS is going to be equal to, I marked up my figure, 1/2 of the difference. Since it met in the exterior, we would be subtracting these. So the measure of angle PRS is equal to 1/2 of 60 minus 14, which is 46 degrees. So measure of angle PRS is equal to 23 degrees. This chart is really a good summary of what you've learned in this section, so I actually really like it. So if you have an inscribed angle, it's half of the intercepted arc, and this is the one that showed up in this section on the right here, which I said is really to me just like an inscribed angle, because it's hitting the edge of the circle there. So it's 1/2 of the arc measure. If you have an angle inside the circle, then it's like the average. It's 1/2 of the two arcs added together. And if you have an angle outside of the circle, then it's subtraction. So half the sum if it's inside. If it's outside, it's half the difference. So subtraction. So the angle's outside. So it's 202 minus 78, and then take half of that, or divide it by 2. Okay, if I'm looking for the measure of arc YZ, so in the end I want this. Well, it's not an inscribed angle, but it's coming off of an angle that's in the exterior. So if I knew this angle, I could just subtract. If I knew that arc measure, I could just find the difference and subtract them. But I don't know those arc measures, so I have to go with what else I know. I see that I have a linear pair in here, so 113, well this is vertical angle, so that would be 113, and I could subtract 113 from 180, and that would be 67 degrees, and this is 67 degrees. So I have my interior angle measures, so remember that an interior angle is equal to 1/2 of the two arcs added together, so that would be the sum of the two arcs. So specifically in this case, the measure of angle X, is that a V? VY is equal to 1/2 of the arcs. So that would be, oh, it doesn't give me a letter. We'll call it A. So 1/2 the measure of arc AY plus arc WZ. So the measure of angle X, we know the measure of angle XVY, sorry about that. That's going to be 67 degrees, is equal to 1/2 of arc AY, we don't know, plus 68. So I can start by dividing by 1/2 to get that out of the way. And so 67 divided by 1/2 is really multiplying by 2, so that's 134. Is equal to AY, arc AY plus 68, so minus 68 from both sides. So the measure of arc AY is equal to 66 degrees. So that's helpful now, because I have one part of what I need. And now with the exterior angle, it's equal to 1/2 of the two arcs subtracted from each other. So meaning the measure of angle x is equal to 1/2 of arc YZ minus arc AY, which we just found. So 49 degrees is equal to 1/2 of YZ, we don't know, minus 66 degrees. If you want, you can distribute the 1/2, or you can divide by 1/2 on both sides, which is really like multiplying by 2. So I get 98 equals arc YZ minus 66. Add 66 to both sides, and I get that the measure of arc YZ is equal to 164 degrees.